warm welcome from me to all of you. So I think it's me and Mubasawala standing in between you all and the lunch. So we'll try to make it as short as possible. Okay, so today the topic what I want to cover is location-based services. So basically when we talk about location-based services, it's just to find where I am, in a map, or where I am in a location or a geography. So that's what we all talk about and how important it is. So I'll just walk through a bit on introduction to location-based services. What are the different types we have, like satellite-based positioning, a short overview probably, and then network-based positioning, and then also very important when we want to roll out and have this in the system or in the mobiles, supporting how to test or what to test then to make sure that this works. So first of all, when you talk about why, the bigger chunk, like we already discussed in the morning, one of the questions came is about the E911 or talked about 112 emergency call in India. So we are talking about here public safety services. So this becomes a very big idea behind why the positioning technologies, the positioning services are very important. Then also to complement this, we have in our daily world, we use a lot of apps, which also tries to help us finding friends, which is through WhatsApp or through Facebook, or which also uses such navigation services in the phone inbuilt, and also maps. Today we really rely hugely on maps for reaching one place to another place. In a new city where we want to find ourselves to reach a destination. So I think we are really started appreciating this kind of services, but more importantly, again to stress this, the public safety services in terms of emergency that we'd like to look into. So when we say that there are some different scenarios available, so we also then look at requirements for testing in also a different way. So like if you see the public safety, it is an emergency, it should be on a top priority, it should really, whenever the emergency happens, within the next few seconds, the call, emergency has to go to the emergency center. So this is, very time-based, and whereas compared to any other, if you are trying to update your location on a Facebook, we need not be that priority. So we need to then really look at, when using these different use cases, how to test and how to prioritize these use cases into when we are talking about. And also there are quite a lot of specifications and test requirements given by different organizations like FCC, then GCF, PTCR, OMA, RCTIA. So this is what we think about, is important, that test requirements are clear and then we really test it and then launch it. So looking at next is what, how basically we do this, how do we do this position, what are the different types of position technologies. One which we already know, we all know about, is about the satellite-based methods, which are like the global navigation system. We always talk about GPS. Of course, a very well-known name. So GPS is again one of the global navigation satellite systems. Apart from that, we have many others like GLONASS, Compass, BDU. Now we are also very proud to be in India and having our own satellite navigation systems, which is just completed the launch as the 7th satellite in the constellation last month. So we have IRNSS, also the Indian satellite navigation system now. So this will all aid in a way to get a position fix for the UE or for the person having the mobile in his hand to know where he is. And then next is, we also think about an alternate methods, which is network-based or mobile radio-based methods. There are two types, OTDOA, observed time difference of arrival, or enhanced cell ID. We'll also talk a little bit on this in the next couple of slides. Then hybrid methods, what we talk about here is a combination of both the satellite-based and network-based methods. So when we talk about satellite-based positioning methods, as I already said, that we are having these different methods. GPS is from the US, and we have a Russian satellite constellation. We have Galileo, which is the European one, and also the Indian one now. So how does this basically work? Basically, when you look at the satellites, we need to get a position information from these at least 3 to 4 satellites. So what does the satellite give information about? It gives information about the map. That means where is the constellation, of these satellites. When I download some information from this satellite, it will tell you this satellite is in the orbit always in that particular point or day and time is in that location. So when we receive the signal from that satellite, we already know that I am somewhere very close proximity to visibility to this 1, 2, 3 or 4 satellites. And then we try to measure the delay in these signals coming from the satellites and say, compare the difference in delay, and with this we can use a triangulation method to say, okay, I am this much far from this satellite, this much close to this satellite, then I can do a triangulation method and then say, okay, now my position can be fixed. So usually 3 satellites should be enough. If you get information from 3 satellites, it should be enough at a particular position to know where I am. But the 4th is also required for some kind of accuracy, for timing information. So this is how the satellite-based navigation works. Now, having said this, how long will it take? So the question is, if I switch on the mobile, can I know the position immediately? With GPS or with GNSS, global navigation satellites, it's not so. Because the satellites are very far away, the data rate is very low in a satellite. So the information what we want to decode from the satellite, this is spread across a very long frame, which means that it takes at least 30 seconds for us to get this information from each of the satellites. So it means the position, the time for the position, first position fix is very long, which is sometimes may be critical because we really don't want to wait in an emergency situation, wait 30 seconds to get a position and then send the information across. So what we look at now is some alternative. What could be an alternative is assisted GNSS, which is called AGNSS or AGPS or whatever. So this AGNSS means that now the base stations which are serving the mobile can already give certain information required to get the first position fix, which means some of the information, the base stations are already prefixed in a location, and it also knows the visibility of which satellite it has. So it can already start giving an initial information to the mobiles so that it will advance the first position fix time so that it can be reduced to around less than 1 or 2 seconds. So with this, we can always work. Still, the mobile requires the other further information from the satellites to track the position fixes. So this is what we're talking about, AGNSS. So one is about the GNSS itself, where there's a long position, first position fix. To reduce this, we also use it assisted. And assisted, it can be 2 types, whether it can be mobile assisted or mobile based, which means that here it's a question of where the calculation is done. The calculation is done on the mobile for the estimation, or calculation is done at the base station. So mobile does a measurement and just gives the information back to base station, and base station does the calculation. So this is some 2 modes that can be used in AGNSS. Now, okay, we saw that we can still get a good early position fix with less than 1 or 2 seconds, which is quite good for a location-based service system. But what is now important to know is, are these satellites, at least minimum of 4 what we want, visible to us in each and every place that we are in? So there are some critical scenarios, or like very critical scenarios, which means that there is possibility that when we are inside buildings or indoors, and some of the bylanes, where narrow lanes, where you cannot, the signal from the GPS is very weak, so it doesn't reach there. So you will just go out of sync, and then further position fix is not possible. So in this case, now what do we do? How do we really look at it? So this is where now we think of the alternate system, what we talked about, which is the network-based system, or mobile radio positioning, also what can be called. So if you look at quickly what is in offer here is, we also see that the bandwidth requirements are very low on the GNSS based satellite-based systems, whereas the high bandwidth is what is already operational on the mobile radio systems. Very interesting could be here to see that the GNSS satellite-based system is a line of sight, requires line of sight, whereas the network-based can also work with non-line of sight. So this is the satellite-based is 3-dimensional, whereas the network-based is 2-dimensional. So now let's little bit look into now what is now this network based and how this can be done. Okay. So before we also just looked at, just to say that in LTE we support all this, which is that we also support the assisted GNSS based, we support the network based, which is now the OTDOA or UTDOA are enhanced LID. So if I talked about enhanced LID as one of this kind of system, we already said. Then we have observed time difference of arrival, and this is usually in the downlink, and in the uplink we say it's the uplink time difference of arrival. So and let's look a little bit into what this has to offer. So when we talk about such a system, there are two parameters that we need to look into. One is for a particular position fixed through a network-based, what are the measurements necessary and who is doing this measurement? What is the entity? Whether it is the mobile, the UE is doing this measurement, or is it the base station doing this measurement? So based on that, we have something like whether it's a UE based or a network based, UE based or UE assisted or network assisted. So we see, and then the second one is who is doing the estimation. We have the measurements now. From the measurements, we need to do a calculation to get into where the position of the UE is. And for that, again, we need to look into who is doing this estimation. So in LTE, we always have this information processed by a location server. So location server is sitting in it's an entity which can sit in a network anywhere, and then the information, the measurements are sent to the location server, and the location server is calculating the position fix and then giving it back to the UE, that this is now your position. So the table just gives an idea about the different types of system. Like if you look at the satellite based, it can be working as both UE based or UE assisted. When it comes to the OTDOA, the network based or enhanced LID, there is now also some variation that now it's more UE assisted, because the position estimations are not done any longer in the UE. It's always done on the position location server in the network. So what we also know from now, like when we talk about a cell ID means that we always know that the mobile that we are using is linked to the serving cell, which means that it is within the area of the service cell. But this is still not enough, because we need to know the exact position. Like some of our friends were talking about earlier, that the requirements could be as accurate to 50 meters. We need the position fixed to be as accurate to 50 meters. So now we just try to enhance now the cell ID with a concept that now if the mobile is not just taking the cell ID from the single serving base station, but also now it takes the cell ID from neighboring base stations. And now it tries to calculate how far I am from each of this base station. This can also be done by the reference signal received power. So the received power is also an indication is from how far I am from the base station. And the position of these three base stations are already fixed in the geographical plane. So we know where are these base stations. So knowing now how far I am from these base stations by measuring the cell ID from three different base stations, from the received power I know, then again from the triangulation method, I can know the position, where exactly I may be in the vicinity of these three base stations. And that way I can also find my position without now any satellite-based navigation system present. So this is again a good alternative, because as we discussed, in some scenarios where there is no GPS signal, then this can be really critical, because we also talked in the morning and also in sessions that now E911 or 112 emergency service and public safety is really going to be mandated. And it's very important that we are connected, we are being approachable in terms of emergencies. So the other thing what we also see is when there is only one serving cell and there is no neighboring cells, maybe you are in an outskirt area where you are at the end of the signal reception of a particular cell and something like that, and scenarios like that. Is it possible again to do a position fix? The answer is yes, because we can try to use the different technique with just measuring one base station, but using the angle of arrival. For this angle of arrival, we need to really know from which direction is the signal coming from the mobile. For that, we need to really have a good implementation of antenna arrays at the base station, so that it can measure the angle from each of the arrays, then you can really say, okay, now the exact angle from the base station for this UE is 35 degrees or 95 degrees or whatever. And then again, the distance will always can be calculated from the received signal power. So that then we can also, then with the AOA, angle of arrival method, we can still try to find a position fix. So we see already now that since the enhanced LID ESET method, there are two possibilities of measuring or trying to find out the position fix. Then the other concept we're talking here now is about the OTDOA or UTDOA, which is the observed time difference of arrival, or we talk about uplink time difference of arrival. The difference is that whether it's a downlink or an uplink. So whether the measurement is more done on a downlink signal or a measurement is done on an uplink signal. So for this, in the release 11 of LTE, the GPP, we have a new reference signal in the downlink signal, which is already induced, which is called the position reference signal, PRS. The PRS now is a frequency spread and time spread in the bandwidth in the downlink. So that now, if the UE now tries to measure and measures this signal, and the same signal is also transmitted from the neighboring base stations. Now when it tries to measure this different PRS signals from 3 different base stations, now and also observes the difference in time from when it has received the PRS from the first base station, when it has received the signal from the second base station, it can also now form a hyperbola and again with the triangulation method find the position fix from the hyperbola, from the 3 hyperbolas. So this is again another way of determining position in LTE. So we talked about ESET with then 3 different ESET measurements from 3 different base stations. Now we also are looking at angle of arrival as another way with just 1 base station. And the third thing also could be with the uplink, downlink with this hyperbola method, using the positioning reference signal. Just to mention, if it is an uplink UTDOA, uplink time difference of arrival measurement, then we don't use PRS because PRS is only transmitted in the downlink. So we use this SRS, which is transmitted in the uplink LTE. Okay. So this just summarizes the different technology part what we use. Quickly to just say what can be tested or how to test. Now this is basically what we see, the satellite constellation or the position, it's more a field related measurement. Now how do we bring this to bring in better quality of service and to ensure that this works? How do we bring this field measurements to the lab? This is another way what we can do is a kind of a record replay solution that we offer this. So the idea behind is to now with some kind of a GNSS recorder setup, record the whole situation, what is there in the field, and then then this can be more or less more geographically location-based measurements, recordings which can be done. Then we can replay the same in the lab, so that we can test the performance of the DUT against different scenarios, whether how the position fix is we are able to attain, and under whether each critical situations, whether we are able to meet this position fix or not. And also, when we talk about network-based or satellite-based, under which scenarios, which kind of method is better to use? Whether should we go for a satellite-based under this scenario, or should we go on for a when do we make the shift in a UE? When should the UE decide that I should go now for a network-based to a satellite-based or vice versa? So this can be really easily simulated in a lab environment, and the algorithms can be more well defined for the mobile, so that we are always accurate when we talk about position fix. So when we talk about testing, there is whole requirements coming. This is quite a big topic, so we didn't really go into more details on how exactly the messages are exchanged and things like that. So there is a whole lot of test suits and requirements, as we talked about different organizations giving the requirements. So we have some minimum performance, protocol conformance with I think in the morning we talked about one of the distinguished panelists said that most of this SMS position information, it will go on the control plane. So the moment we say it's going on the control plane, then it is important to know whether how good this message exchanges over the control plane is happening. So we need to do some protocol conformance tests for that. Then of course, operator acceptance. Each of the operators, they can specify for their network what will be the test plans, that how they want to do the testing for this, and then we can do. So if you see, like we also now trying to engage in India for most of the Indian operators to see how we can bring out a solution to do such measurements and bring out some very specific test requirements in discussion with them, and then offer solutions for that. So in short, we have some capabilities. We have a setup which can do just the GNSS or satellite based part, and across also not just LTE, but it can also do satellite based navigation or position fixed measurement, location based measurements on 2G or 3G also. And we also have a dedicated setup for the network based. And this can also be mixed. The setup can be mixed to measure the hybrid scenarios, which could be then shifting between network based and satellite based on the scenario that can be available. Okay. So with this, I just want to end my presentation. Thank you very much.